Hello, my name is Daniel Wiseman, a student at Full Sail University. My professor for physics is Thomas Oateson, and this is my physics video project for October 26th, 2015. Now, my program is video game design. Now, one thing that's in every single video game is gravity, whether it's simulated with a physics engine or just implied with things not floating away as we walk through the environment. It's in every game. Now, I know you may be thinking, well, space games or games with zero gravity don't have gravity. Well, the lack of gravity is simulated. So from a design perspective, it's in every single game. Now, as video game designers, we need to know how gravity affects the world around us so we can accurately simulate it, because when things aren't accurately simulated, players normally notice and it stands out to them. Or does it? Now, I'm going to run some tests to see how accurate some video games that are hyper realistic or claim to be hyper realistic actually are. Well, one game in particular, and it's one action in particular that I'm going to show you, and then I'm going to run some tests to see how accurate it actually is, or if it could actually be achieved, even though the game claims to be realistic from that standpoint. Watch this. Now, that was pretty cool, but could it ever really happen? Can someone actually survive a fall from that height into that hay bale and survive? There's a particular reason I chose this game, and let me show you. The building in the scene is the Saint-Germain-des-Prés in Paris, France, and it still exists today. Being as the building is still around, I can say with accuracy that the height the figure jumped from was 62 meters high, and from that I can figure that if he was 2 meters tall and roughly 200 pounds, he was traveling at roughly 32 meters per second at the point at which he contacted the hay bale. We can see from this image that from the top of the bale to the base of the wagon can't be any more than 1 to 2 meters high, meaning that the man in the picture would have to decelerate from 32 to 0 meters per second in a span of 2 meters without sustaining more than 50 to 75 Gs, which is sufficient enough of an impact to have clear potential for serious injury or death. Okay, so I know what you're saying. A egg is not a sufficient human analog to test this. Well, if you think about it, it might be. Now, this egg is roughly 2 inches tall, or most eggs on average are roughly 2 inches tall. The man in the image and the man in the game I told you about was 2 meters tall. So that would be 1 inch. I know I'm swapping between the system's metric system and American system, but you're gonna have to go with me on this. That would be roughly between 1 inch for every 1 meter. Now, I know that if I dropped an egg from 64 inches in the air, or 2 meters in the air, it would be traveling at roughly 1 meter per second when it struck the ground. So that's 36 inches per second. Now, if we scale that up, you'll know that if I drop that human in the picture from the same height at 62 meters high, he's traveling at 32 meters per second. Now, like I said, it's not perfect, but it's still pretty close from 32 inches, from 36 inches per second to 32 meters per second is, if we're doing the 1 inch to 1 meter, that scale is pretty close. Now, if we take this and say that a crack in the shell is, potential for injury, right? And a catastrophic shell failure is, obviously serious injury or death, then this can actually fall from a fairly decent height with these foam pieces of tape around it to act as sort of the outer body. Being as humans don't have a shell around them, they have something that their fat and muscle and skin actually absorbs quite a bit of energy, which is why you need something to simulate that on an egg, because humans aren't rigid, and when they fall, they're not going to stay rigid. So there's going to be something on their body that absorbs the energy, and that's what this is going to simulate. And with this egg can actually fall from a sufficient enough scale height, which would be scale around 40 feet in this case, and it would might crack from that scale height, but it wouldn't break. And that's close enough to what a human could withstand, to where I can sufficiently say that most likely if I drop this into a scale hay bale from 64 inches high, if it cracks, that human is injured, and if it does not, obviously that human would maybe be okay. Now, that's obviously provided the human didn't hit any of the sides, and there's a lot of factors, and there's also a lot of outliers. I mean, humans can fall from huge distances and still possibly survive. I'm just saying, reasonably, could they survive? So I'm going to conduct the test, and we're going to see what happens. The egg is traveling close to 2 meters per second at the point of impact, and displacement is shown as both the cotton and the egg cannot occupy the same space, throwing the cotton into the air as the egg descends into it. The cotton, that was set to almost 3 meters in scale, was not able to slow the egg down enough to keep it from cracking, but it was enough to avoid a complete shell failure. While this means that someone definitely could not fall 62 meters into some hay and simply walk away, there is a possibility that they may actually live. But this is not the whole problem. Not only does the character have to survive a fall of 62 meters, which we now know they most likely could not do, but they would also have to propel themselves forward with enough force to reach the hay bale in the first place. This picture shows the hay bale is 19 meters forward of the point from where the character jumps. So they would have to launch themselves with enough force to clear 19 meters before gravity completely took over and they began falling straight down. This is a simple 2D simulation I made to test whether or not it was actually possible for someone to jump that far. The simple structures are to scale with the buildings in the game. I configured the simulation to apply the max amount of force a human could apply with their legs from a standing position. As you can see, in the simulation, gravity takes over almost immediately, and while the figure gets close, they don't quite make it. This concludes my physics project for October 26, 2015. Thank you so much for watching.